The second part of the interview with Schneider Electric's Steve Carlini focuses on the role that the edge has to play when it comes to 5G. I'm guessing that the underlying infrastructure for 5G, the IT infrastructure is obviously mission critical in many, in virtually all cases, I guess. But the edge, and I know we've discussed in the past how you define an edge, because it could be quite a large data center that just happens to be not in the middle of where a organization is operating, right down to these little kiosks on street corners that maybe will eventually control autonomous vehicles, whatever. But yeah, can you just talk us the role of the edge as you see it in terms of 5G?
Yeah, so like I said, 5G. So the 5G is going to have a cloud computing architecture. So you're going to have what's called the core. They call it the core cloud architecture. Then closer to the users, it's going to be a metro. So the metro architecture is going to control the coordination of all the local edge or the MEC data centers. So it's a multi-layered cloud, and the reason that you have to have this cloud is because you have these incredible specifications for performance and speed and low latency. So the content that's going to be delivered through this network, and the processing of all of the data is going to be done locally. And locally meaning in what they call a community. So you have a coverage map, and the coverage map is dictated by what the projected usage is going to be in that area. So in urban areas, the coverage map for like one MEC data center could be very small, could be as small as a small building, and you could have in a square kilometer you could have multiple mobile edge cloud data centers. We're saying right now, before the rollout and based on all the testing that we're seeing, you're going to need a ratio of between 3.5 and 5 data centers as compared to 4G, where they had the base stations at the towers. So you're going to see these mobile edge cloud and each one of these is not going to be associated with the tower, but you're going to need the processing closer to the users. So each one of these is going to be our estimates are going to be around 10 kilowatts average, and they're going to go on tops of buildings, they're going to go in basements, they're going to go in parking lots, and they're going to be the kind of the local edge for the processing. On the even closer to the user, you're going to see things like small cells that are going to be built into the light poles, and those are going to communicate back to the mobile edge cloud. And sometimes they'll do those through the air. Sometimes they'll communicate through fiber optic, which is something that people don't really conceive when they think about 5G. They just think it's all through the air and it's all through the radio access network. But 5G is really a combination of wired and wireless technologies.
And it might seem slightly sort of counterintuitive, if that's the right word, that you've just sort of explained an infrastructure where you're going to be rolling out sort of many more data centers and a lot more IT components. But sustainability is obviously the IT industry, I guess, is under a certain amount of pressure, its environmental footprint. So does sustainability have a role, I guess, within this sort of 5G, the rollout of 5G?
So, 1, 2, 3, 4G, they were all done mainly, with performance of the network in mind, but the performance of the carbon footprint or the electrical use was really not a consideration. So with 5G, it is rising to the top because of the massive scale that we're predicting, for the data center rollout, which is, we think, going to be around 7.5 million of these MEC data centers worldwide. So when you're deploying, at that type of scale, we're talking about 130 gigawatts of power, which is a tremendous amount of electrical uses. So OpEx, in these types of companies is, that's a big portion of an OpEx. If you're going to be managing, if you're a carrier, you're going to be managing, and owning a lot of this network of mobile edge cloud. So what we're trying to do is package together solutions, that are the most energy efficient possible. They do pull a little too much power, around 10 kilowatts. So you could do some kind of solar, but you would need a pretty big solar field to be able to power that much. So it's really about the efficiency. How efficient can you make these mobile edge data centers from a performance perspective? There's ways that you can interface with the applications to put them in different states of idle when they're not being heavily utilized. So the electrical footprint and the carbon footprint is going to be massive, and we're working on different ways to make those efficient as possible. And because they're in areas that aren't traditional kind of IT spaces that are climate controlled, and clean, you have to make them so that they can stand up to a harsher power environment. So things like lithium ion batteries, they're less susceptible to heat and to cold. And you have to have new technologies, or think about new technologies for cooling, that are quieter, because some of these are going to be in areas that may have people walking by a lot, or actually working in. So they have to be quieter, and they have to be lower maintenance because of the scale that you're deploying them at, and because of the access to the sites is going to be a little bit more difficult. So things like using some kind of liquid in the cooling architecture, maybe a way to do it to eliminate the air filters. So we're working on different types of designs to make these as edge compatible or harsh power environment compatible as possible, and as efficient as possible to be environmentally friendly. And a big part of that also is the management software that you're gonna need for these types of deployments. So the original kind of data center management software was all kind of bespoke, and it was all you do a data center management per site. So with these types of applications, you're going to be deploying at scale, so you're going to be sending all of the information to really to a cloud-based management system. So a cloud-based management system gives you the ability to look at your entire installed base, and be able to view all of your applications you could look them on a geographical basis, you can just sort it up by numbers, but you can use the data in multiple ways. You could use the data to benchmark all the sites to see if they're performing as well as they're supposed to be. And you can look at them in ways of, you can run analytics on the sites if you're deploying at scale, and saying, with this temperature, with this many discharges, with this profile, we've seen this % failure. So you could have like pre-warning failure before anything goes bad. So that has a positive effect on availability. And if there's any maintenance that's needed, you could do, using analytics and AI, more condition-based maintenance than break-fix type maintenance. So cloud-based management systems, whenever you have to do any kind of configurations or threshold setting, you can do it on a mass basis and not do it one-on-one. And one of the big problems with deploying at scale is information overload. So you want to be able to filter out what you want to see and be alerted on, just to whatever your tolerance is and what you see. So if it's a critical type of situation, then you may want to be notified of that. But we are making it easy to roll up the data from these mobile edge cloud sites through a gateway, sending them to the cloud, and then exposing the data that we have through an APIs. So APIs bucketize the information, coming from all these sites into different buckets, and you could choose to build your interface in any way you want by using the APIs through these sites.
And I mean, I was going to ask you a bit about the sort of service delivery aspect of 5G, but I think quite a lot of what you've just talked about, obviously the reliability, resilience, whatever of the infrastructure, I mean, are there any other angles when it comes to that sort of service delivery part that need to be explained? Or
yeah, so there's the software aspect of it that's critically important, and then coordinating that with a base of service personnel is the other part of it. So obviously these are going to be, because there's such scale, obviously Schneider doesn't have 500,000 service people. so we're going to have to rely on an ecosystem. So an ecosystem of partners that's going to be able to go to these sites and perform the maintenance. Then there's cool stuff you can do with 5G as well, where we're doing a Zoom meeting now. There's new service models that are being developed on the Zoom platform, which are kind of interesting, that you can guide unskilled personnel to perform basic types of service based on the new technologies that are coming out, like Zoom.